line graph. When you have time related data such as what we have, right, and when you depict trends, the line graph is better than the rest of the graphs to depict trends. Click on a blank empty space. You see this? This is a line graph, line chart, line graph. Click on this, please, and you get this. You have axis, right? So this is y, this is x, right? So let's populate something on the x-axis. Drag date and populate here. Okay, nothing yet. Let's do revenue on the y-axis. So just these two things, date, x-axis, y, revenue. You can actually quickly change the face of the graph you want to. And again, go to this. You can go to markers. Example, you can switch on markers. All right, and you can certain degree influence the type of marker. You can actually click on the size of the marker and stuff like that. All right, you can do lines you want to. Not really now. Okay, let's leave it like that. Coming back to this, do you see this hierarchy already? By design, right? If we have date values, Power BI desktop date, it actually compresses down into hierarchy of things. So that's why we see this by default. All right, so the first level is year. If I drill down, second level is quarter, month, and so on and so forth. And this by day, if it's useful at all or not. If I want to go up to the highest level, then there it is. Okay, see this unit sold here. Revenue is much more than unit sold. It's small, no? If I take this right now and I drag and drop this to y-axis, it's gonna look like a flat line because the units here are smaller. Okay, it doesn't make sense. So this is the primary y-axis. You can create a secondary y-axis on the different scale just for units by dragging and dropping it right here. I'm gonna take this, drop it here. This is a secondary axis right here. This is a primary. Look at the scale, is totally different. So now I can see that units has a trend and it's not a straight line. Okay, does it work on your side, guys? Okay, go.
Yes.
So we have the second graph up here. Do you see this icon here? We're just gonna go to this icon here. This icon for analytics. I've selected the second graph. A bunch of stuff, right? Trend line. Yeah, trend line you want to. Okay, and you can configure it accordingly, whether it's dash and etc. and things like that. I can switch on the forecast here. I want to see this forecast thingy. Now what about, you see this gray line here? This is the forecast results. We can actually change stuff if you want to. Forecast length 10 points. Now we're actually talking about years here, right? It's definitely going to be not 10 years now. So seasonality, confidence. So you see these points here? We can actually drop it down. See right here. You see this? Because now these are in years, no? So that's why it's forecast up to 20, 30 plus. Okay. We can switch to maybe months. Example here. Okay. This one 12 months. Does it work? 12 months? Not refreshing. Apply. Click and apply. You see, it didn't refresh, right? So apply. So now you see it's shorter. This gray area is actually the forecasted area. All right. You see this thing here? Do you see confidence interval? Now, what is it about? It's got something to do with this thing here. Something that we learn in school, guys, and something to do with this normal distribution. This bunch of stuff. Now, what about this central limit theorem? Just to refresh ourselves, right? It's something like this. If you got a big bunch of data, right, something more than 30, we break it, that let's say you got 10,000 items now, we break it on 10 groups. So 10,000 items, break it into 10 groups, right? Each of the group we take an average of each group and we plot it on a graph. All right, so I'm just going to try to draw a bell-shaped curve, which is not that straight, right? Okay, if we plot all those ranges, all those data points, right, those values, they will hover around the average of the entire 1,000 items, the population. That's why you get a peak like that, because all those items, right, they tend to hold. You see, you got 10,000 items, you break it up into 10 groups, right? Those 10 groups, they each got a mean, right? They also got average. When you plot it on a graph, right, they will all hold around the average of the entire 10,000 items. All right, that's what the central limit theorem says. That's why you get a peak on top. And the normal distribution says that if the data is balanced, all right, you get a bell-shaped curve like that, and your mean, right, your value actually cuts through right across, and the portion on the left and right, they're actually symmetrical. Okay, I'm explaining this because that option there doesn't shade any light. It expects a person to have this understanding when doing things. All right, and you might have noticed that just now there's a 95% confidence interval in that option there, right? That 95% confidence interval is like this. Interval means range. What range are we talking about? Say if we have a bunch of data, right, and we obtain a range, we obtain an average out of the bunch of data. It's 1 point. Okay, it's 1 point. Okay, so it's just 1 point. Okay, that average actually represents that whole bunch of data. Okay, but there's also other ways of representing data, not with a single value, but using a range to represent that bunch of data. So we are talking about that range here. So that 95% thing, right? Okay, confidence interval is a range, and that 95% is actually area below the graph. Okay, this thing here. Where am I pointing to? Is this one, right? I click on this and I click on this, and this one here, see right here, I'm talking about this confidence interval, 95%. Okay, that interval is the range. All right, that 95% is this 95%. What does it mean? It is back to probability theory. 95% confidence intervals means that there's a 95% chance. 95% chance. All right, of what? Of the true value. The true value of the entire whole bunch of things here. All right, it will be in the shaded area. That's what it means, in that range. That's what it means. This 95% chance, right? This thing here is changeable, because if we click on this, right, it can be any percentage that we want. The default value is 95%. Okay, it has a historical basis to it, because back in the 1900s, mathematicians started with 95% all the time, so it's stuck until today. Okay, so that thing here, we can actually clearly see there's a range here. You see this? It's kind of like a bell-shaped curve. 95% shaded area. Okay, so that is our forecast inside here. All right. Okay, we got a bunch of other things. This is the look and feel of the line, basically. All right, you want to change it to different color, you can. That range here. Okay, so forecast, and it has a formula. This whole entire line has a formula. If you are doing this, sometimes you are asked what's going on, what's the background, or things like that. So that formula is actually this cool stuff that we've done before. Okay, this is the formula. What is it about? A is when the line, this whole line, right, cuts the graph on the y-axis. B is the slope of the graph, which every line has a slope. Okay, the slope is actually, let's say we have a graph like that, right? The rise divided by the run, you get a slope. All right, okay. Okay, any questions surrounding this? I know it's a mouthful of things, but that's the background towards this forecast thingy. Because if you are doing forecast, and it's a good visual, because it allows us to do forecast without calculations. But sometimes we are asked, hey, what's the basis of those things, and what's this about, this shaded area thingy? All right, that thing. So just trying to provide some background to that, all right, in a very short way. Okay. Okay. Oh yeah, before we go for lunch, forget, we gotta take a photograph, documentary evidence. Okay. Okay, I would like to create another graph from here. Create empty graph here, one more. So right here, date, revenue, and I very quickly I want to grab things like markers, their labels on. Okay, so this is a third graph. Okay. Okay, what to do? Third graph, huh? Do you see this? See this? Can you click on this arrow, please? Can you look for something here? You see this date hierarchy? Can find, guys? Still with me? Okay, great. Date hierarchy is this. We got a hierarchy is very clearly here. We get this is a hierarchy. Can you click on date, please? Change this. No hierarchy. See what's happening? All the data points flooded into here. You can go up to 3,000 data points, but you don't really have to go to 3,000. Even 100 data points, right, is already too crowded on this line graph. Okay, let me zoom up. So this is without hierarchy, guys. Whether it makes sense or not is another story. All right, and just now, earlier, before the change, was hierarchy. Okay, it was grouped according to this stuff here. And of course, we can always modify, take out things if you want to by just clicking on the X as usual. All right, does it work? No hierarchy. You see, you can't drill down. You see this? See this thing here? There's no icon to click on because there's no hierarchy to drill down. It's just everything bunched up together. Not that it's useful. Okay, so this is no hierarchy, and I'll save it up, and I would like to name this as line chart, please. Okay, guys, any questions, guys? Very quiet, huh?
Hello, Vincent. This is Talia. One
Hey,
question
hi.
regarding the date there. If I just delete, for example, I delete the day and the quarter there, is that possible that I can move it back after if I change my mind?
Oh yes, this one, right? You can always do this. This thing here. Okay, save date, maybe anything at all. So what you have here, well, It's like, hey, where the rest of the stuff and all, right? Now, easiest way to do it is cancel off the whole thing, drag and drop back the original.
Oh, okay.
Yep, that's the fastest now.
Okay.
Okay, yep.
Thank you.
Yep.
Vincent, yeah.
Yep.
There is an interesting on the forecast just now. Okay, normally we receive the forecast number or the budget, the fixed amount. How it's work for this function? Because actually, from my understanding from this chart, actually the forecast number is generated from the actual value that you drag in the chart, right?
Yes. The basis behind this is linear regression, and that's the formula representing this. Okay, this y and x. All right. It talks about this. Okay. Do you see this equation? Y equals to something something. It says that y is dependent on x. So we talk about what's dependent and what's independent variable. Y is a dependent variable. X is an independent variable. Identifying what's independent or dependent is important when it comes to predicting numbers. Forecasting or budgeting is predicting numbers. Why? The reason is if X causes Y, so Y is dependent on X, right? It says that X is driving Y. Whether it's a cost or it's a revenue, the driving factor or variable is X. So we are using Y to represent a single year or something like that. So we can actually move forward with this. So that's the model of linear regression.